Hi, I'm Joy. I'm an analytics developer on the EIM Analytics and Innovation team. We've put together this webinar as an introduction to big data analytics here at TD, specifically focusing on the HEAT platform. In this webinar, we'll start by introducing HEAT and its infrastructure. We will introduce the toolset that is available on HEAT, as well as the Spark ecosystem. We will go over some examples of projects that have been developed using HEAT, as well as some important considerations if you would like to start using HEAT for your projects. Lastly, we will go over the next steps for you to get started with HEAT. Part 1, Introduction. Before viewing this webinar, it is recommended that you have an understanding of basic Hadoop concepts and TD's Hadoop ecosystem. This includes EDPP, the Enterprise Data Provisioning Platform, and its ingestion and extraction processes. What is HEAT? The Hadoop Enterprise Analytics Tool, or HEAT for short, is the enterprise platform to facilitate the development of analytical artifacts. This includes predictive models, machine learning models, and other data-driven insights. Its Hadoop environment offers speed and tooling that is unparalleled. Its processing power can accomplish analyses not previously possible at TD. It allows access to Hadoop tools for feature engineering, complex modeling, visualizations, and much more. HEAT is part of the Integrated Data and Analytics Ecosystem, or IDNA for short. HEAT receives data from the Enterprise Data Provisioning Platform through the Marketplace Data Store. The TD Marketplace Data Store allows the user to browse data from EDPP. EDPP's integration with the Permissions and Access Record-Keeping Application, or PARC for short, allows the Marketplace Data Store user to request permissions to extract a file into HEAT. Capabilities within HEAT include predictive and advanced analytics development, data discovery, advanced fraud analytics, and customer journeys. Users of this platform are often data analysts and data scientists. Data requested through the Marketplace Data Store is moved from EDPP into HDFS within HEAT. HEAT is a cluster of on-premise machines running CDH, which is Cloudera's distribution of Hadoop. The metrics in this diagram illustrate the processing power of the cluster, which includes 10 terabytes of memory, 2.3 petabytes of storage, 63 nodes, and 2,000 cores. Users can access the cluster through the Edge node. This is a single node with 256 gigs of RAM, 1 terabyte of storage, and 8 cores. Some tools are only available on the Edge node. Using these tools will not leverage the full capability of the HEAT cluster. It's important to note that the security and permissions are managed by the tenant space owner, who may grant directory access to users or user groups as required. Part 2, Toolset. HEAT's big data processing and cluster computing is running on Spark, an API library framework for large-scale processing, querying, streaming, and visualization. Spark's native machine learning library, called ML, uses the power of the entire HEAT cluster. We will get into more details about Spark later. HEAT supports many programming languages, including Scala, which is Spark's native language, Python on Spark, known as PySpark, which offers many libraries for machine learning, visualization, feature engineering, and more. Hive is recommended for batch queries, and Impala is recommended for interactive queries. There are also many available Hadoop tools on HEAT. This includes Spark Streaming for stream processing, Spark GraphX for graph processing, Apache Solr for searching and indexing data, Apache HBase, which is available for column-oriented NoSQL databases, Apache Pig, which is used for scripting, and Spark SQL, which allows for structured data processing. The Hadoop ecosystem. Many of the applications in the Hadoop ecosystem run on Yarn, which stands for Yet Another Resource Negotiator. Yarn acts as a distributed operating system. It controls the resource management across the cluster. Some applications run directly on HDFS without using Yarn, such as Cloudera Impala. All of the distributed data is stored within HDFS. What is Apache Spark? We've mentioned HEAT offers Spark, but why is it important? Spark is a fast engine for large-scale distributed data that uses in-memory processing. Spark reads from the disk, stores the results of intermediate jobs in memory, and then writes back to the disk at the end of the job. This is significantly faster than intermediate disk input-output, which was seen previously with MapReduce. Spark's higher-level API allows for faster and easier development. On the right-hand side, we see Spark's API call compared to the equivalent MapReduce code. Spark's low latency allows for near real-time processing, and Spark's in-memory data storage provides up to 100 times performance improvement. Spark facilitates the implementation of both iterative algorithms that visit their dataset multiple times in a loop, and interactive and exploratory data analysis, for example, the repeated database-style querying of data. For interactive data exploration using Spark, users can choose to use Scala in the Spark shell or Python in the PySpark shell. Users connect to the Edge node using an SSH client, such as PuTTY, and begin their data exploration by launching the shell of their choice. Hive can also be used this way. Another way to interact with data in Heat is to use Hue, which stands for the Hadoop User Experience. Hue is a Cloudera product which offers a user-friendly interface to interact with data in HDFS in many ways. Hue provides query editors for Hive and Impala, as well as file browsing, job browsing, and easy-to-use data visualization. To develop applications on Heat, it's recommended to use a development interface such as Eclipse or IntelliJ. Apache Maven is leveraged to download the Spark and Hadoop dependencies and provides a uniform build system for packaging your software. Nexus is used as TD's internal repository to store and distribute the software components. And for code collaboration, Bitbucket is available to use, which uses Git as its version control system. Part 3, Projects. Heat can be used for any project based on the machine learning workflow. The tools available facilitate data exploration, feature extraction, feature selection, model building, model evaluation, as well as predictions. Let's take a look at some examples of projects built in Heat. Lifestyle Attributes Analysis. Leveraging Heat, this project was able to build a comprehensive customer profile for every customer in the TD database in 30 minutes. It used 11 million customer accounts and 8 terabytes of data that spanned 60 months and 20 billion transactions. The result allowed them to identify customer affinity to 600 interest categories and identify areas where customers were using competitor products. One of the findings from this project was that grocery shopping and gas pumps were the interest areas where competitor products were used most. Personalized next best product recommendation. The goal of this project was to predict the next product category a customer is likely to pick up in the next 3 months. This included credit cards, investment, demand checkings and savings, loans, mortgages, and lines of credit. This project was built end-to-end on Heat, including the data transformations, the feature engineering, the predictive modeling, and handling the data skewness. 70 binary and multi-classification models were built for 35 segments of customers. There was consistently better evaluation results than the implementation done previously in SAS. Griffin, fast-tracking model development on Heat. Griffin is a high-level, easy-to-use framework built on top of Spark, which encapsulates the complexities of the model development lifecycle. It vastly reduces the number of development effort required, as well as the deep understanding of the Hadoop ecosystem. Griffin was accepted into Strata Hadoop Conference 2017, which is the first project to be accepted from any Canadian bank. It provides a framework for common analytics use cases, such as propensity models, for example, the likelihood of someone closing their account, as well as sentiment analysis, which is a feature that's currently in progress. Griffin is available for tenants to use on the Heat platform. TD Wealth have used Heat for a number of projects. The goal of the TD Wealth Compliance Project was to determine if an investment advisor is likely to receive a regulatory complaint. This was the first analytics project built on heat that will be going into production. The Direct Investment Project aimed to upsell investment clients to options trading. Heat was leveraged to build and analyze over 3,700 features, and Griffin was used to train and evaluate dozens of predictive models. Part 4, Considerations. Here are some important considerations if you're interested in leveraging heat in your project. 1. EDPP is the only approved source of data to be loaded into heat. That means data brought into heat by any other means will trigger a TRIMIS, privacy, and audit alert. Potential tenants are encouraged to ensure that the data that is required exists in EDPP. If not, they are to work with the application owner of source data to ingest. 2. Disaster recovery and backups. There is no defined process or SLA for the heat platform. This means that the tenant sandbox should not be used to support ongoing operational efforts. 3. Business as usual. Tenants are responsible for the alignment, attestation, and ensuring adherence with privacy, legal, and TRIMIS standards while using this platform. 4. Privacy Impact Assessment, PIA. Tenants are responsible for managing processes to gain relevant approval for any PIA related with the use of their platform. 5. Personal identifiable information and payment card industry. Data considered PII or PCI, depending on levels of approval, will be obfuscated before landing on heat while maintaining the linkage keys. Part 5, Next Steps. The business owners of Heat are the enterprise customer data and analytics marketing team, supporting Heat and EDPP. Their connections page is linked for your reference. Please reach out to them if you have any questions regarding the following: applying for a Heat tenant space and assigning users, the process to move data into EDPP and Heat, the process to move models from Heat back into EDPP for frequent use, and getting access to the try before you buy version of Heat. The technology owners of Heat are EETS, Enterprise Information Management, Big Data Analytics, and Innovation. Their Confluence and Connections pages are linked for your reference. Please reach out to them if you would like to learn more about the following: collaborating with business teams on advanced analytics projects, developing innovative solutions inspired by known business problems, assisting with the transition and migration to the Heat platform, including training and onboarding, and extending the core capabilities of the Heat platform by researching, evaluating, and recommending appropriate tools. If you'd like to learn more about Spark, here are some helpful links to get you started. All URLs mentioned in this webinar will be sent out via email upon completion. Thank you for viewing the Heat webinar on Big Data Analytics at TD.